The observatory also offers a rare view of the moon.
I hope everybody's doing well. This is Globe-Proof Backfire number 2, and this is going to be a good one. There is so much wrong with this.
We need your globe just like a moose needs a hat rack. We need your outer space like a steaming pile of shit stack. We don't need your globe. We don't need your model. We don't want your globe. We don't want your model. Where on God's green earth did you come up with this model? Why was this ever taught to you? Then tell us why you retarded. Tell us why you retarded. Please 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 tell us why you retarded. Where on God's green earth did you come up with this model? Why was this ever taught to you? Then tell us why you retarded. Tell us why you retarded. Please tell us why you retarded. Please tell us why you retarded. Please tell us why you retarded.
Funny shit. Man, I crack myself up sometimes. But here's your first major problem. That's the moon. A good full moon. What is that on the left? It surely ain't the moon. The moon's on the right. Now I know space is shady, but is it also shady? Because the supposed satellite that took this image is in Lagrange point 1, in between the Earth and the Sun. So it can only get a full moon. Just don't look real. I mean, let's be honest. It don't look real. Let's familiarize ourselves with all the orbits. Make sure we don't make some false claims. So it says a geostationary orbit is actually a type of geosynchronous orbit. The key difference between a geostationary orbit and a geosynchronous is while the latter, or geosynchronous, can have any inclination, and the former, or geostationary, is permanently parked over the plane of the Earth's equator. So how is that even an orbit? If it's just sitting up overhead and it doesn't move, how do they even call that an orbit? Well, whatever. Anyway, that's claimed to be 35,000 something kilometers, or about 22,000 miles. And it's parked straight overhead. So that backs it up some more. Let's look at the next one. The next one is medium Earth orbit. It's GPS satellite's orbit. And it is at about 20,000 kilometers, which is about 12,500 miles roughly. And they're claimed to be going 7,000 miles per hour. So we got the low Earth orbit, or where the ISS is, claiming to go 17,500 miles an hour. We've got the medium Earth orbit, claiming to do about 7,000 miles per hour. And then we've got the geostationary, which is claiming to be parked over the equator. So what would we call that speed for geostationary orbit? 0? I guess if it's parked over the equator, then 0.
Geostationary satellites can see the entire planet and let us watch the Earth evolve by using multiple satellites to build a full picture.
No. That is a problem. They're showing 5 geostationary satellites, okay, when we just read that it's parked over the equator. And if it's in a sweet spot or Lagrange point, whatever they call it, then it's right in between the sun's gravity and the Earth's gravity, then it can't be on the other side of the Earth, or it'd have the sun and the Earth pulling it straight down. So that's a big fail.
Adam Sabo, Discover project scientist at NASA's Goddard Space Flight Center, says, "The Discover mission provides a new and complementary view of Earth. Discover floats at the first Sun-Earth Lagrange point, L1, a sort of gravitational parking spot for spacecraft. Here the gravitational pull of the Sun and Earth cancel out, providing a quasi-stable orbit."
So it says here that L1, Lagrange point 1, is almost 1,000,000 miles from the Earth. Okay, so he just showed us previously 5 satellites around the Earth and called that geostationary. What would that make them in L1 half? No, we got to be missing something. Let's dig a little deeper.
A partnership between NASA, NOAA, and the U.S. Air Force, this mission's primary objective is, in fact, to help NOAA provide timely space weather alerts and forecasts. The observatory also offers a rare view of the Moon.
Or more accurately, a rare view of not the Moon. Is it a full moon or a fool's moon? They really screwed the pooch on that one. Like, I could see him at the office. "John, what the hell is this? The moon is dark." "Yeah, it's the dark side of the moon, Bill." "No, dude, it's an L1. It can only be a full moon." They got to turn it into their boss at NASA. He goes up, he's like, "Hey, boss, here's that image of the full moon you asked for. Bill told me to give it to you." Alright, so they claim that the satellites in low Earth orbit, like the ISS, are doing 17,500 miles per hour. And they say that there's gravity up there. They're just going fast enough to be constantly free-falling. So we'll check the numbers and we'll compare that to the GPS speed and altitude. So we want to get the distance that the ISS travels, or the circumference. Okay, so we're going to add 250 miles to 3959 miles. We get 4,209. We're going to multiply that times 2 pi, and we come up with 26,445. Okay, so we divide that by 17,500 miles per hour, and we get 1.51. So that checks out. So 1.5 hours or 90 minutes. Now let's check the GPS satellites. So they're claimed to be at 12,550 miles, and they're claimed to be doing a speed of 7,000 miles per hour. Okay, so we take the 12,550 miles altitude, we add 3959 to that to get the radius, then we multiply that times 2 pi, we get 103,729. That's the circumference of the orbit. Okay, so we divide that by the 7,000 mile an hour speed, and Houston, we seem to have a problem here. It says every 14.8 hours we do an orbit, when they're claimed to do them in a little less than 12. And they can't just claim gravity's less up there. That doesn't make a difference. If you're doing that distance in that amount of time, the gravity ain't got shit to do with it. You've got to do it in said time. And so something's off here. Also, they can't just say like an elliptical orbit, because that's about a 20% difference. Between a little less than 12 hours and 14.8, that's a significant difference. So I'm looking forward to hearing the explanation for this, because usually when something like this happens, something is afoot. They use them numbers to explain something else, because they don't generally make mistakes with the numbers. So something is afoot, but even still you got problems with the 0 miles per hour stationary orbit, and this is obviously fake as shit. So that turns this into a globe-proof backfire. Plenty more to come. Thank you for watching.